Well, a balanced chemical equation is also a recipe, but it's a recipe for how reactant elements, atoms, molecules combine to form products. So let's look at a simple one. 3H2O plus N2 gives us 2NH3. And we can draw pictures. Pictures can be real helpful. So this tells us that 3 hydrogen molecules would react with 1 nitrogen molecule, and we could make 2 ammonia molecules out of that. So if you think of these as being like Lego blocks, you can envision pulling these guys apart and sticking them back together, and using all of these pieces, you could make those 2, right? That's what a chemical equation is describing. Well, if we had 3 molecules to 1 molecule, but we could also have 3 dozen to 1 dozen, we could also have 3 moles to 1 mole. Remember, the mole is a chemist's dozen. A dozen is 12. A mole is just that crazy huge number instead. Same idea. So from this chemical equation that's balanced, we get mole ratios, just like we did with the pancakes. So we can say that there are 3 moles of hydrogen for every 1 mole of nitrogen. There are 3 of these for every 1 of those. There's 1 mole of nitrogen for how many moles of ammonia, NH3? 2. For every 1 mole of this, we get 2 moles of that. There are 2 moles of ammonia for every 3 moles of hydrogen. Everybody okay with that? So what I did in this equation is I just inserted the unit mole. Because like in cooking, if I had 2 dozen eggs, 2 eggs would make 5 pancakes. 2 dozen eggs would make how many dozen pancakes? 5 dozen, right? 2 eggs makes 5 pancakes. 2 dozen eggs makes 5 dozen pancakes. The numbers are the same, we're just changing the unit. So we've got these mole ratios in the equation here. Okay, so let's practice with these. If I have 3 moles, oh, wrong color. If I have 3 moles of nitrogen, and I have more than enough hydrogen, how much ammonia can I make? This is a lot like the pancake question. I want to find out how many moles of NH3. Dimensional analysis tells me I should put the unit moles of N2 down here to make the units work out. The numbers come from the equation. 1 mole of nitrogen makes 2 moles of ammonia. So I put 2 in front of moles of ammonia and 1 in front of the nitrogen. And then I just do the math. 3 times 2 divided by 1 is 6. So I could get 6 moles of ammonia. Does that make sense? So whole numbers are always nice, but we don't usually have whole numbers. So how many moles of nitrogen are needed to completely react with 7.13 moles of hydrogen? This was like the eggs and pancakes. I have this many eggs. How much flour do I need to use those up? Well, so I've got 7.13 moles of hydrogen. And what am I trying to find? Moles of nitrogen. So moles of nitrogen is what I'm trying to go to. If we're going to write out a path, we've got moles H2 to moles of N2. So moles of H2 to moles of N2 I want to divide by moles of H2 because I want the units to cancel out. This chapter is the biggest reason that you need to learn dimensional analysis. So if you haven't figured it out yet, now would be a great time to do that. I can help you with that. You just have to ask. So what's the ratio here of nitrogen to hydrogen? It's 1 to 3. There's one of these to 3 of those. 1 nitrogen to 3 of those. So can't really do this one in our heads. At least I can't. 7.13 divided by 3. We'll pay attention to significant figures here, and this would be 2.38 moles of nitrogen. How many sig figs do these numbers have? Infinite. They're exact, okay, because these come down to numbers of particles, counting units. In one NH3, there is exactly 1 nitrogen atom and exactly 3 hydrogen atoms. You have exactly 3 H2 molecules combined with exactly 1 nitrogen molecule to form exactly 2 ammonia molecules. So these coefficients are exact numbers. What that means is that however many sig figs you started with, that's how many you end up with. Any questions? One more example. So water forms from oxygen and hydrogen, explosive. How many moles of water would result from the complete reaction of 24.6 moles of oxygen, assuming there's more than enough hydrogen around? Well, the idea here is that we're given number of moles of oxygen, and what are they asking us to find? Moles of water, right? So that's our path. So 24.6 moles of oxygen. There's one arrow. We're going to have one fraction. We'll put moles of H2O up there. And then this unit comes down in the bottom. Moles of O2. So these guys cancel out. We don't have to memorize conversion factors. We don't have to go look them up anywhere. They are in the balanced chemical equation. 1 mole of oxygen makes 2 moles of water. 1 mole of oxygen for 2 moles of water. 49.2. Any questions? It's important to grasp these ideas as we go along because it's going to get more complicated. It's not going to get easier. We're just going to add on to it. And so if this is fuzzy, get this cleared up before Thursday.